Hello and welcome to Chapter 2, Section 2, Polynomial Functions of Higher Degree. This is day 1. The first few slides are going to be just copying down for notes. Then there will be some examples. So at this time, pause the video. This shows you the basic shape of a power function. You have two different types of power functions, one with an even exponent and the other with an odd exponent. Please pause at this time. This is about the leading coefficient test. Please copy this down and you'll see examples on how to use the leading coefficient test next. Please pause at this time. Now we're going to use the leading coefficient test. First thing we need to do is find out what n is, and n is the degree of the polynomial, and n is odd. And then we need to know whether the leading coefficient is positive or negative. Well, we can see it's negative, so we say that a sub n is less than 0. Now, if that's true, then we know f of x approaches positive infinity as x approaches negative infinity. We also know that f of x approaches negative infinity as x approaches infinity. Okay, and if you did a quick sketch of that, you would say that as x approaches negative infinity, it's up, so it's going down like this. Okay. Next, we have n is even, and a sub n is greater than 0. So we know that f of x approaches positive infinity as x approaches negative infinity. We know f of x approaches positive infinity as x approaches positive infinity. And if we did a quick sketch of that, it would look similar to a parabola. Okay, our last one, the last example, n is odd. But this time, the leading coefficient is positive, so a sub n is greater than 0. So that changes up things a little bit as f of x approaches infinity as x approaches infinity. F of x approaches negative infinity as x approaches negative infinity. And that's going to be a graph that looks similar to this. Now you need to copy down the notes on zeros of polynomial functions and real zeros of polynomial functions. Pause the video now. Now we're looking at repeated zeros, so pause the video now. Now we're going to put everything together. We're going to describe the end behavior, find all real zeros, determine the number of turning points, and determine the multiplicity of each zero. First, let's start out with the end behavior. Well, to help us with end behavior, I'm going to put it in order, so that would be equal to negative x squared plus 49. That tells me that n is even and a sub n is less than 0. Since I know that, I know f of x approaches negative infinity as x approaches infinity. And that also means that f of x approaches negative infinity as x approaches negative infinity. Okay, now the next thing we want to do is find the zeros. So that's going to be 49 minus x squared equals 0. Equals 0, not 2, 0. Okay, so we just factor that, and that factors as 7 plus x, 7 minus x. Okay, we set that equal to 0, and we see that x equals negative 7 and positive 7. Okay, next thing we want to do is find out the number of turning points. Well, we do n minus 1 to find the number of turning points. So n was 2, so 2 minus 1 is 1 turning point. The last thing we need to do is look at the multiplicity. Well, that means how many times did the answer happen? Well, the negative 7 happened once, and the positive 7 happened once. So the multiplicity of each 0 is 1. Our next example also is even, and a sub n is greater than 0. So n is even, and a sub n is greater than 0. So as f of x approaches infinity, x approaches infinity. As f of x approaches infinity, as x approaches negative infinity. Okay, next thing we need to do is find the real zeros, so we factor. So first thing I would do would be factor out the 1/2, and that gives me x squared plus 5x minus 3 equals 0. Okay, as we can see, that is not easily factored, so we're going to have to plug it into the quadratic formula. And when we plug it into the quadratic formula, we get x equals negative 5 plus or minus the square root of 37 all over 2. Those are my real answers, or my real zeros. So the next thing I need to do is find my turning point, and my turning point is n is 2 minus 1 equals 1 turning point. Okay, now as I look at my zeros, I see the multiplicity for both my zeros, negative 5 plus the square root of 37 over 2, and negative 5 minus the square root of 37 over 2. Both of those, the multiplicity is 1. So this one has a multiplicity of 1, and this one has a multiplicity of 1. And that's it for today. I hope you had a wonderful time. Thank you. Bye.